Understanding 555 timer. The IC 555 is one of the most popular and most widely used ICs. It is a versatile and extremely robust integrated circuit that is used in many applications like timers, wave generators, pulse, and oscillators. The IC 555, popularly known as the 555 timer, was developed by Hans Kamensinde of Signetic Corporation in the year 1971. It was released in two parts, NE 555 and SE 555. The NE 555 parts were of commercial usage with a temperature range of 00C to 700C, and the SE 555 parts are designed to meet the military standards with a temperature range of -550C to 1250C. It is a monolithic IC and was the first commercially available timer ICs. Features. Some of the important features of the 555 timer are: the 555 timer can be operated at a wide range of power supplies ranging from 5V to 18V. It is available in 3 different packages: 8-pin metal can package, 8-pin dip and 14-pin dip. Timing can be anywhere from microseconds to hours. It can operate in both actable and monostable modes. High output current. It has an adjustable duty cycle. It is TTL compatible due to its high output current. The output can source or sink a current of 200 mA to the load. It has a temperature stability of 0.005% per 0C. No more from 555 timer datasheet. Different modes of operation. Generally, the 555 timer can be operated in 3 modes: astable, monostable, or one-shot, and bistable. Astable mode. In this mode, the 555 work as a free-running mode. The output of astable multivibrator will continuously toggle between low and high, thereby generating a train of pulse, which is why it is known as pulse generator. It is a best example for a perfect square wave generator. They are used as an inverter and also used in many of the internal part of the radio. Selecting a thermistor as a timing resistor allows the use of the 555 in a temperature sensor. Monostable mode. Butterworth polynomials in coefficients form is tabulated as given below. In the monostable mode, as the name suggests, it stays in its stable state until and unless an external trigger is applied. In this mode, the 555 functions as a one-shot pulse generator. The best application of a monostable is to introduce a time delay into a system. Applications comprise many things, viz., timers, missing pulse detection, also included bounce-free switches, touch switches, as well as frequency divider, capacitance measurement, and pulse width modulation, PWM, and many more. BIST-able mode. In the BIST-able mode, the IC 555 acts as a flip-flop as it has 2 stable states. It can be used to store 1 bit of data. It is not a great choice for implementing a flip-flop. Pin configuration of 555 timer. The 555 timer is available in 8-pin metal can package, 8-pin mini dual inline package, dip, and 14-pin dip. The 14-pin dip is IC 556, which consists of 2 555 timers. The 8-pin dip is most commonly used. The pin-out diagrams of 555 timer in both the 8-pin packages is shown below. The names and numbers of all the pins along with their descriptions are tabulated below. Pin 1, ground, GND. Ground reference voltage, low level 0V. All the voltages are measured with respect to this terminal. Pin 2, trigger terminal. It is responsible for set and reset transitions of the flip-flop. The amplitude of the external trigger pulse will influence the output of the timer. The output goes high and the timing interval starts when the input at trigger pin falls below half of control voltage, i.e. 1/3 of the VCC. Pin 3, output terminal. Output-driven waveform is available at this pin. It is driven to 1.7 V below VCC. Two types of loads can be connected to the output. One is normally off-load, which is connected between pins 3 and 1, G and D, and the other is normally on-load, which is connected between pins 3 and 8, VCC. Pin 4, reset terminal. A negative pulse on this pin will disable or reset the timer. The timer will begin only when the voltage on this pin is above 0.7 V and hence it is normally connected to VCC when not used. Pin 5, control voltage. It controls the threshold and trigger levels and hence the timing of the 555. The width of the output pulse is determined by the control voltage. The output voltage can be modulated by an external voltage applied to this pin. Generally, it is connected to ground through a 10F capacitor when not in use in order to eliminate any noise. Pin 6, threshold terminal. The voltage applied at this terminal is compared with the reference voltage of 2/3 VCC. When the voltage at this terminal is greater than 2/3 VCC, the flip-flop is reset and the output falls from high to low. Pin 7, discharge. It is connected to the open collector of the internal NPN transistor which discharges the timing capacitor. When the voltage at this pin reaches 2/3 VCC, the output toggles from high to low. Pin 8, VCC or supply. A supply voltage in the range of 5V to 18V is applied to this terminal.